Good morning, everyone. Hopefully everybody can see me. If you can see me, just give me a quick little type there and let me know that we're live and all is going well. I'm going to share my screen with you guys in a second now, so we can just get the presentation up. Great, thanks. I see some thumbs up there. Excellent. Thank you everybody for being here this morning. I know it's slightly early, it's 9 o'clock in the morning. So today's talk, so Cloudy with a Chance of Responsibility. So my name's John. I work for a company that you might see on my shirt here, and specifically for the cloud area of that company. So I've been in InfoSec officially from a job perspective since 2002, and then as like with most people, a way to get into InfoSec is playing around on the internet and discovering stuff. So I've been messing around with things way before 2002. So enough about me, let's get into what this talk is about. So firstly, just a little bit of a warning. This talk is going to contain these following items, which is time travel, unicorns, onions. There may also be some dragons, some bow ties, and some breaks as well. So stick with me. Hopefully at the end, all of this will actually make sense. I know probably right now you're scratching your head to say, what is this guy thinking? But it should make sense in a little bit. So let's continue on to the unicorns. So yes, I'll start with that. So a couple of facts about unicorns. So the earliest record of unicorns in Western literature is in about the 5th century. A Greek historian, Theseus, wrote that the beast had a white body, purple head, blue eyes, multicolored horn, as you would expect, obviously, a unicorn to look like. Then Marco Polo in his travels believed he stumbled across unicorns. He wrote they were very ugly brutes to look at, not at all such as we describe unicorns. That's because he actually discovered in his travels through Asia, he discovered rhinos, so obviously you can see the disconnect. We also see in 1560, German merchants sold a unicorn horn for an astronomical price of 90,000 screws, about 80,000 euros, which is still quite a lot of money in today's economy. And pharmacies in London sold powdered unicorn horn as late as 1741. And then the last point here, which I quite like, is since 1971, a university in the US, in Michigan, has issued hunting permits to unicorn questers. They say anybody embarking on such a journey should carry a flask of cognac and some pinking shears. Now, you probably need the cognac and the pinking shears because it only makes sense to have those things once you've had a couple of glasses of cognac, I think. So, what does unicorns have to do with any of this stuff? What does it have to do with security, right? So, we all know that, well, unless you live in Scotland, because in Scotland the national animal is the unicorn, but if you live anywhere else, I think most of us should know that unicorns are a myth. And that's the same when we speak about moving to the cloud. So there's this myth that moving to the cloud introduces more risk. Hopefully through this talk, I'll show you that that's not really the case. Obviously, when you do new things, there's always some type of risk, and some risks are new, but it doesn't necessarily introduce more risk. So let's just pump the brakes here for a second on this one. And the reason why brakes are also here, so if we go back to security, right? An analogy that oftentimes gets used, that I use quite a lot, is brakes. Security is like brakes on a car. And if we were in the room together, all of us, I'd actually do an audience question now and I'd ask you, what do brakes on a car do? And the typical answer that I would get is brakes make you stop. To which I would say, that's not really true, because brakes actually make you go faster. It allows you to accelerate, because if you didn't have brakes, you couldn't go fast, right? And that's the same thing with security. If you have good security, then it allows that acceleration. Obviously, we know if we have bad security, no brakes, then we do have challenges in that. Another way to illustrate this, and this is where the bow ties basically come in. So if you think about, a lot of times we're trying to protect information. We're essentially trying to protect data in some form, right? So if you take the skeleton of a bow tie that I've very crudely drawn here, and the knot would be your data in the middle. So if you have where the little thumbs up is at the bottom of the screen, if you have good security, leads to high innovation, happy people. If you have bad security, now the emoji there plus the acronym will also give you another way of calling that type of security. It leads to low innovation and unhappy people, right? Now, to kind of illustrate that, right, we say security equals innovation. Let's put that into a context of Google, right? So Google obviously has a lot of products, and Google Cloud is one of those things, one of the entities. So obviously we have things such as Chrome, Android, Gmail, all the good things that you know, and then the enterprise services like cloud as well in there. And we have, obviously, as you can imagine, quite a lot of users that we need to protect on a daily basis. So let me put that into perspective by showing you some of the threats that we see from a Google perspective. And this is not a new thing. There was actually a presentation about this at Next 2017, where the guys dived a little bit more into these things. So what type of attackers do we typically see? So we see everything from lone wolves, script kiddies, insider risks, obviously down to the most sophisticated, which is nation-state actors. And many of you folks on this will actually recall that in 2009, 2010, Google actually had a nation-state event. It was called Operation Aurora. I'm not going to go into all the details. It's public record and all these kind of things. And Google actually came out and said, we've had this issue with the nation state. And that also was one of those elements where it changed a little bit in the InfoSec circles. Because before that, nobody actually spoke about these things. And Google came out, and once we had said we discovered this, there was around 20 plus other companies that came out in this space that actually said they had also experienced the same thing. In our case, it made us rethink how we did security, because they did end up breaching our perimeter. Luckily, we picked them up early enough, and not a lot of damage was done. But it made us rethink how we do security, and we'll come back to that a little bit later in this talk. So how are they typically attacking? So obviously we see everything from DDoS, spear phishing, malware, cross-site scripting, all those things, down to obviously 0 days. What do they typically want? Depends obviously on the actor itself. If it's a criminal organization, I have to sort of belligerently tip my hat to them. They're very good at monetizing everything. It's typically about money. If it's a nation state, it could be intellectual property or espionage, etc., etc. So those are the things that we have, for instance, in our threat model. And that's why I can say that, going back to those breaks and the bow tie analogy of security actually equaling innovation, if that wasn't the case in terms of like Google and Google Cloud, we would have one of those matrix moments now where I would take the pill and I wouldn't actually be speaking to you, because we wouldn't exist as an organization if we didn't have that in place. So before we get into the typical people, process, and technology side of things, I just want to put kind of 2 design principles out there when we build anything. So the first thing is, when we design things, it needs to be security that just works. Now, an important part of this is, it doesn't matter how smart you are, how big your budget is, how many security defenses you have. If you make security too hard for users, people will actively try and work around that. And it's also around the usability of it. So A good example of this is you see a security key on there. We all know passwords aren't the best thing in the world, right? They were good at that time potentially, but the world's moved on. So we know having a second factor is really good, multi-factor authentication. But one of the challenges with multi-factor authentication is why it hasn't been so widely adopted at times, is if you think about it, when you're trying to put in your password, then your second factor is an SMS, and I have a very short attention span. So if it takes a while for the SMS to arrive, I've moved on to the next thing. It's a bad user experience, right? It's the same thing with a long authenticator code. Now, don't get me wrong, having these things are still much better than just having a password by itself. But if you think about those things, you get back to that point where you're busy typing in your 18-digit code, and just as you're about to hit the last character, it expires. Bad user experience. So that leads to users not necessarily adopting it. In comes security keys. Got a security key here. So these are things that are meant to protect against remote attacks. Obviously not local physical attacks, but remote attacks. So in this case, all I have to do is tap that security key, and my second factor is done. That's a much better user experience. And we actually in 2017 rolled this out across the whole of Google, so everybody has this basically. And we saw 100% of account compromises stop from that perspective. So security that just works. That's the first design principle. The next one is the traditional model. So hopefully everybody has had breakfast and this egg doesn't make you too hungry right now. So the traditional model is like this egg, right? So the way we've typically done security, we build a very hard outer shell or a hard outer perimeter. But then once you crack through it, there's a soft inside. I mean, the joke that I make is you can lateral move like it's 1999 in a lot of networks once you're through the perimeter, because it's very trusted networks. And like I mentioned in 2009, 2010, with that Aurora thing, we had this kind of model. But since then, the lessons we learned from that actually made us move to what's called a zero trust environment, where essentially nothing on our network is trusted, but it's around the identities and in context that then set those boundaries. And it doesn't just rely on the traditional, hard outer shell. So we operate zero trust, and that's where the whole zero trust concept comes from our learnings in that. And I think there's, off the top of my head, I think either 6 or 7 detailed white papers on this concept already and the learnings that we've gone through that. So if you want to go read it, I think you might know a search engine that will help you find those. So let's talk about cloud security, and we'll get into some of the cool tech stuff and all those things in a second as well. So how do we build that house kind of thing? Firstly, again, just some principles just to show you that Google Cloud is a slight bit different than the other businesses. So Google Cloud is obviously enterprise business, so it's a little bit different. So you control your data, not Google. We don't sell your customer data to third parties. It's not used for advertising. We're transparent about the way that we use the data and collect the data. It's all there in the service terms. You can go and read it on the site. We guard against insider access. We never give any backdoor access to any entity. And then hopefully through the next part, you'll actually see security and privacy are primary design criteria for all our products. So let's start with the people side of things. So from the Google side of things, in the people side of things, we obviously have things such as Project Zero. So some of you folks might be familiar with Project Zero. That's a team whose aim is to make 0 days hard and actually try and push the industry to work on products and patch them faster when there are vulnerabilities. And we've actually seen quite a few of those things out there in the past. Notable ones obviously have been things such as Heartbleed and Spectre and Meltdown, and there's many other ones around there. And then there's also our threat analysis group, TAG. You may have seen some things recently in the press around some things that they basically published about campaigns targeting security researchers. You actually see it on this one. I'm not going to go too deeply into that, but that's a group of people whose job is to do that kind of research. We also have things such as Project Shield. So Project Shield is basically helping activists, journalists, people that are susceptible to getting DDoSed and helping protect their properties. Very notable one was was Brian Krebs, that after exposing the Mirai botnet authors got hit with a large DDoS attack. You can go read it on Krebs' site of how Project Shield helped him out. So there's a bunch of these things that happen. So the research side, and then there's also folks that are responsible for protecting our platform and the security engineering that goes into our products, along with the privacy and all those kind of things. So that's just to give you an idea of the people side of things. Now, when we get to the process side of things, this is something as a cloud provider that we have to do as well. And it also gives you as a customer transparency in that sense, if you then tend to be a customer. So here you see all the different audits and certifications that we have. It's an ever-growing list. Firstly, you see the things such as ISO 27001, 27017, which is specifically on cloud security, 27018, which is around the privacy relationship between the CSP and the customer. All those things are basically there. You see all the different ones in the different areas. Obviously, GDPR is there, which is an important thing. And then you'll see things such as the SOC 2. So one of the important things is trust is created through transparency, right? And if you can't be transparent about these things, how can you trust it? How can you trust the things that I say? So, for instance, on that point, you can actually go to our site and go and download a copy of the SOC 2 report, which will get watermarked, obviously, to your name, but you have a copy of the SOC 2 report for Google Cloud, so you can actually go and see the independent audit around those kind of things. So those are the things that we do from a compliance and regulatory kind of standpoint, and then obviously the audits, so you can actually also verify that. So security is in everything we do, and we're going to get into that a little bit more in a second. So here we get into obviously the onions, because security should also be like an onion. There should be multiple layers, and every layer that you cut through should make you cry. So if it's the attacker, it should be very unpleasant. They should be wasting a lot of resources, essentially making them cry in that sense. So let's start with the physical side of things. So, excuse me. As you can imagine, from a physical perspective, we have all the things that you would think about from a data center. So there's multi-layered biometric identification, there's multi-layered gates, things such as man traps, metal detection, cameras, video analytics, vehicle barriers, down to laser-based intrusion detection systems as well. And then another thing that's also there, just going back to the threat model as well, it's not on the slides here, but we also have sharks. So that's a slight bit of a joke, but we do have to protect the undersea cables that connect our data centers, our transatlantic cables, from sharks. So some of you might have seen a picture in a news article of a shark trying to bite through one of those things as well, because that's one of the things that people also don't realize is the scale of these network, that we actually have our own undersea cables from that perspective. So those are the things on the physical side of things. Now, there's obviously a 9-layer stack when it comes to the security side of things. So here we already start with one of those 9 layers, and I'll show you guys a slide in the next one where it shows you those 9 layers, going back to that onion. Here we have the layers, right? So here's Titan. Not to be confused with our Titan security key for the second factor. This is a different kind of Titan chip. We've actually open sourced. There's an Open Titan project as well that you can go read around some of these things. But this is a purpose-built silicone that helps us establish a hardware root of trust. And this is actually one of our network controllers that you see this on, so that we can actually also make sure that we have that trusted platform module built into the environment. This is what the infrastructure basically looks like, right? So we start all the way from hardware. So you saw the purpose-built chips with the Titan controller in there. We have purpose-built servers. What a lot of people don't know, probably between, at any given time, is probably between third or fifth biggest, compute and storage manufacturer in the world. Obviously, we only build it for ourselves and in the form of cloud for our customers to use. So we have these things where we basically strip out everything that's not needed and we just build it for the purpose that's there. It's the same with the storage, the network, and the data centers. We build it for what it's supposed to be. And that helps you from like a risk and a threat perspective, because you eliminate surface area for those things. So I'm not going to go into every part of these things because we'd probably spend way more than an hour just going through all these layers. So I'll pick out a few things that'll be of interest, because I want to save a few minutes at the end to see if there's any questions from you folks. So the next part up is obviously trusted boot. So, and once you have trusted boot, and you already saw the Titan chip there, which helps establish that trusted boot. Without going too much into the whole trusted boot, I'll show you a slide on it, but the whole process. Basically, Titan has the ability to hold the CPU in a reset state to first check that nothing has been messed with, and then actually releases. And a lot of TPMs or secure boots basically do, after the boot process verifies that, which is a bit of a strange thing to do in my opinion, because if you messed with that beforehand, you won't know if something happened. So we take a bit of a different approach, and we actually hold the CPU in a reset state. And once those checks have happened, then you have your trusted boot, and then we assign cryptographic credentials to it. So each machine in our fleet has those cryptographic credentials. Then we have a hardened KVM hypervisor, which actually helps with the isolation and the multi-tenancy of things. There's actually a blog post that you can go and read about it, the 7 ways we harden our hypervisor. So it's also something that's been custom written with security in mind. Now on the storage layer, so this is an interesting thing. I think a lot of folks are now starting to follow this trend, but in the beginning we were the first ones that didn't give you an option to encrypt or not encrypt. So by default, you can encrypt. Everything is encrypted on Google Cloud, right? At rest. So once the data is stored at rest, it's by default encryption. Now, I'll make a little bit of a controversial statement here. Encryption is easy. Key management is the hard part, right? I'll get into that a little bit later, but from a cloud perspective, we give you as the customer lots of options basically around encryption. So it's either there and it's all managed by the system, or you can manage it through a cloud KMS backed by hardware HSMs. You have the ability to have fully external keys in the form of external key managers, customer supplied encryption. So there's a myriad of options for this. And just to get a little bit deeper into the encryption address. So uses envelope encryption. And what basically happens, it's data shards. So the data is broken into shards, and then these shards get data encryption keys, and then there's a key encryption key that unwraps this. So think about it of taking a needle, breaking it into 1,000 pieces, putting it across 1,000 different haystacks. So you just mix all of it up, and then giving each piece its own data encryption key. That's how you should think of encryption address. So also everything in the environment is logged around that. Won't get too much into that stuff. The network I already mentioned is a very large scale network. It was custom built to enable to sustain, the volume that we have to output from that perspective. So true software-defined network, everything is built from that layer kind of up. On the application side, I'll pick up two things that are super, well, I think they're super cool. And some of them have actually made their way into the cloud. So from the application side of things, we have source code and image provenance. Now, this is obviously a tech thing that makes this happen, but it's also a cultural thing that makes this happen. Because normally, if you tell developers in any environment, hey, look, we can trace back each line of code to, who wrote it and why it was written, people tend to get nervous because they worry, like, am I going to get fired for that line of code that I wrote? Now, when I joined Google quite a few years back, we have this thing called onboarding, which is called Noogler Bootcamp. So Noogler. And in my one, I got told of the engineer that brought the whole of Google down. And that engineer didn't get fired. That engineer got promoted because that engineer was making some changes and then a whole bunch of infrastructure started failing. It wasn't a very long outage, but it was still an outage. And in that case, the engineer acted responsibility. He didn't try and fix the problem, always roll back. But in that case, it wasn't the engineer's fault because we have a blameless postmortem. And in that case, basically what happened, all our automated code checks had failed. The way we designed our infrastructure had failed. Our code approvers had failed. A whole bunch of things had failed in that scenario. So that's also a cultural element, and that gives people also that safety that, that they can act responsibility. So there's also another added benefit to that. And it also, obviously, from a security perspective, if you can trace where the code has come from, you can actually spot if this code should be there and if it's code that should be operating in your environment. Now, kind of related to that is binary authorization. So we basically have the concept of making sure that all the binaries that execute on an environment is authorized. So if you have binaries that are authorized, then let's say, for instance, malware is uploaded into your environment. That's not an authorized binary. So then that should, in theory, not execute. And this is also a thing that's now available to folks on the cloud where you can actually go and use the binary authorization tools around that. So on the deployment side, obviously, we have our own certificate authority. So for all the things that we do in our underlying stack, there's TLS with perfect forward secrecy employed. When we get to the operations thing, one I'd like to pick up here, which is a very interesting one, is the live migration, maintenance, and patching. So we have the ability for the underlying stack. So I'm not saying the virtual Windows machine that you run on the environment, that you still have to go and patch yourself if you're a customer in that environment. But for the underlying stack, we basically have the ability to take workloads and then migrate them in real time and patch the underlying stack, which really is a really good thing to have, because one of the challenges that's always there in InfoSec is from time to vulnerability to patch. And this allows that to happen in a very, very fast manner. And then on the usage side, as I mentioned, everything is basically logged. We have safe browsing APIs, the whole BeyondCorp model, which is the zero trust model, and then security key enforcement. So those are the 9 layers. There's a lot more into these layers. Just to kind of illustrate what I mentioned, the trusted boot, here you basically see that power on happens, then the hardened BIOS gets on the bootloader, the kernel, and the hardened OS image. And then once that's all run through and all the checks, like I mentioned with the TPM stuff that happened, these things then get a cryptographic signature. So if these things actually don't happen, what will basically happen to that server is it will just basically get put back to reset state, and a technician will get alerted to come and fix this. So that's an illustration of that. Like, those layers are much more involved. there's quite a few talks that delve more into some of these things that I would suggest you actually go and check out as well. This is just to also show the encryption that I already mentioned. So what I didn't mention is each disk itself is also encrypted. So you have that sharding process, but the physical disk itself is also encrypted. So even if you were the world's best ninja and you managed to break into a data center, evading the man traps, the biometrics, the laser beam intrusion detection, security guards, all those things, even if you broke in there and you managed to grab a disk, well, the disk itself is also encrypted. And then the data on top of that as well. So you actually see there's the hardware, then there's block storage, the infrastructure. Then on the platform, there's also, on the database, there's also the ability for encryptions. And then on the application side, you as a customer can also still then build in additional encryption if you needed to. And then there's just one last thing. Again, going back to that, how can you trust something if you can't verify it, right? So as a lot of you folks will probably know, and I mean, since it's HackOn, a lot of the security folks know a thing or two about vulnerability rewards programs. So we've had an active bug bounty program for quite a while now. And startupgoogle.com is in scope for this. So obviously cloud is definitely in scope for this. And from a cloud perspective, we've taken a little bit of a different stance here. So you don't need to notify us if you're going to perform penetration testing or vulnerability scanning. You do have to abide by the acceptable usage and terms of service. And these are things such as, if you're testing, for instance, your environment cloud, obviously stick to your own environment. Don't go and test the competitor's thing. That will lead you to different issues. And also, stick to the platform as well from those things. So read the terms of service and acceptable usage policy. But if you stay within those things, you don't actually have to inform us if you're going to do any testing. And the reason for doing that as well is if you think about an attacker. So let's think about somebody trying to burgle my house. No burglar is going to come to my house and say, by the way, can I come to your house on Tuesday and is it cool if I break through the back window kind of thing? Attackers don't test that way kind of thing. So that's why we say you don't have to notify us. And if you do find something, we will pay you a reward, if it fits into the bounds of what that is. With the noted exception, if you're obviously working for a company and you have an ethics department and there might be some things that say that you're not allowed to accept the reward, then you will probably just get a lousy t-shirt from us. So I have a real world case of this when I started in Google Cloud a couple of years back. Like I spoke to some folks about this, a customer, and they went and they tested and they actually found some information you could show. They didn't find a vulnerability, but still, it wasn't good hygiene. And they sent me the POC. I validated it, and okay, cool, it worked. I took it to the internal team, and the internal team had actually found it a couple of weeks before, and they were rolling out the patch. They were getting ready to roll out the patch. But they said, look, this customer did find something, so, let's pay them a reward. And literally with this customer, there was some issues with their internal ethics department. And I literally had an email of the customer just saying, can I get a lousy t-shirt? In the end, we managed to work it out with the ethics department and stuff. But that's why this t-shirt study is there. Now, let's get back to that title. So the title said, Cloudy with a Chance of Responsibility. So this is one of the things. So if you look at a lot of the headlines, when things go wrong from a cloud perspective, it's around the shared responsibility matrix. If you look at a lot of the things that happen, there's public buckets or keys being uploaded, etc., etc. And this is because that shared responsibility is not always that well understood. So if you look at from an on-premise environment, you basically do everything, right? All the way up to stack. When you get into infrastructure as a service, everything below the guest operating system is the provider's thing, and then everything above that, that's obviously up to the customer. When you get to platform as a service, obviously from web application security all the way up to content is your thing. And when it's full software as a service, the access policies and the content are the things that you basically care about. Now, let's get into the time travel thing. And this is also where some of those dragons will be in. So let's go back to time travel. So you may be thinking, what is this? So this is a picture of my fence. Where I live, it can be quite windy. And this is actually the fence that got blown over by the wind. And the reason why I use this analogy in terms of time travel makes sense in a second is, so in this case, the previous owners, when they had put up the fence, they never thought about the wind direction. Like, why would you consider the wind direction when you put up the fence? So the way that they've put up the fence is the wind actually blows in, and the way that it blows in, it actually blows the fence out of its screws, right? So they never considered that. Now, if we take like a lot of the security controls that have been there from a on-premise environment, and you bring it into the world of cloud, a lot of those controls, if we're all honest with ourselves, were actually built before there was such a thing as a cloud. So we're trying to retrofit those controls into the cloud. So that's the same with this fence. We're not considering the wind direction, and we're just trying to put those same things and those same principles into something that's completely different. So that's the thing. A lot of controls were invented before cloud was even there. So that's why I would say you need to consider the wind direction. Go back in time and evaluate those things that you had and actually bring them to the present. So I'll show you some examples on that in the next bit. So to make things a little bit practical, so I told you a little bit about why I think security is important, why it's important in the Google context, how we do some of the things in the cloud environment, but then how do you do some of the things? What are some 4 common things where things get a little bit weird? So hopefully this leaves you in your cloud journey with some practical things that make sense. So number 1 is more is better, but sometimes more is too much, right? A very common thing that happens is over permissioning. And we all know that role-based access control and least privilege are very, very good things because it avoids a lot of these things. For instance, if an attacker gets in, a lot of times the first thing after they've done a bit of recon is they're going to try and privilege escalate. Now, if they come in with root privileges, well, you don't need to privilege escalate. That's a really bad situation to be in. And if you look here at the screenshot, you basically actually see here is in a project, somebody has been granted an owner role, and we have some tooling that helps our customers realize some of these things. But you basically see you could replace this owner role with just a storage object admin and take their permissions from 3,767 down to 9. So you could easily see how things can go wrong in this thing. So more is better, but sometimes more is too much, especially when it comes to permissioning. So always make sure that you only have the permissions for what needs to be done. And there's another concept of that where you can further abstract it away. There's the concept of a service account or a token ID or something, a machine identity in that sense, where it can basically be something that's restricted for a single purpose only in that event and has no human interaction. Because again, if we're all honest with ourselves, a lot of the things go wrong from having people in the mix. So if you can then automate and get a lot of those things up, makes things a lot simpler. So number 1, make sure you grant the permissions that are needed to your thing, and no more than that. Number 2, this one comes up a lot. Don't make things public if they don't need to be, but secure like they are. So here you need to have a mind shift. Work with the principle that things are always open to the internet. So going back to that traditional model, in the traditional model, we always work with, we have very strong perimeter, everything's closed off to the internet. But we should actually be working that everything's exposed to the internet, because it'll change the way that we secure things. And here you actually see this on the slide itself. So you see we have in this environment 214 assets that have public IP addresses, 200 open SSH ports. Now obviously with your favorite indexer, you can go and find these things, whether it's Shodan, Census, you Nmap it, whatever you want to do. You can very easily find these things on the internet. Open RDP ports, open firewalls, so a whole firewall open to the internet. Probably not the best thing. And then there's some other very interesting ones that also appear in this one. You'll obviously see public buckets, 4 counts of that. So we know what's going to happen with that, especially if you put sensitive data in that. Not going to be a very good thing. Very interesting one in this one. And so this is all obviously mocked up slides, but you also see Open Telnet. Now, hopefully no one has any more of those things. I know there are still some cases, but it gives you that idea. Don't make them public, but assume that they are and secure them as they are. What would you do if these things were public? So that's number 2. Number 3, sharing is caring. Oversharing is not. So here you see a little finding called user managed service account key. So that means people have the ability to go and download their private keys. What's a common thing that very often happens is these private keys get uploaded to either public buckets or public repos, and then they are quickly then found and then misused. And then it even compounds the problem if we go back to number 1, which was the over-provisioning of permissions. If you've over-provisioned and you've also overshared, you can see it's not going to be a fun day. So that's number 3. Don't share these things. And you can actually go and set controls on a lot of cloud environments that actually prevent these things from an organizational thing that makes it impossible to actually go and download these things or giving the rights to folks to perform these actions. And then obviously making sure that whichever service provider you have has some tooling that actually picks this up. So a lot of the hyperscalers have this. In our case, we have a thing called Security Health Analytics that actually scans a lot of public repos to actually see if there is any of these things in there. And then number 4. So here I have a fire, and you might be thinking, what does a fire have to do low barrier to entry? Mind the step. Well, it's 2 things. So fire is there to remind me to tell you a bit of a campfire story on this one. And fire can also be there because this could turn into a dumpster fire or a little trash can fire if you don't heed this little piece of advice here. So with cloud, you'll basically see it's a low barrier to entry because anybody with a credit card can, go and spin up some instances. And if you have a little bit of know-how and follow some of the guidances, within a couple of hours, you could have a working application exposed to the internet and serving traffic. So low barrier to entry. It's not like in the past, if we wanted to do a thing, we had to go, okay, I want this service, I need to size these things, and I need to go to a procurement department to go and order these things. and then it arrives and it's the wrong thing after a couple of weeks, and I have to send it back. And after a month or few, then I actually start getting into testing and all these other things. A lot of those things can happen, weeks and sometimes even in hours. So low barrier to entry. Now, the story that I'll tell you is in the Netherlands and in the Czech Republic, in the Netherlands it's called Buurman and Buurman, which is called neighbor and neighbor. In Czech it's called Pat and Nat. It's this kid's cartoon basically of these two neighbors that are the kings of over-engineering. Now, because in cloud you'll also realize that you can also automate a lot of things and do a lot of cool things. Now, these two neighbors, basically in one of the cartoons, the one neighbor is mowing the lawn, and as he mows the lawn, he cuts over the lawnmower cord, and obviously it stops working. Now, as the kings of over-engineers, the other neighbor immediately has this brilliant idea. So you see him run up and jump onto his roof, and he rips off a solar panel. Now, they take the solar panel and they strap it to the lawnmower. Now the lawnmower starts going by itself, automation. And that's one of the things that you can realize in the cloud. Like the low barrier to entry, you can go, oh, it's very easy to automate things. So that's really, really good. But then what happens, it's going around their garden and it goes around this big bush that's making a big shadow. And then obviously the shadow cuts out the solar panel and the lawnmower stops working. So then what these guys do, they basically go and chop down every tree and every bush in their whole garden. Great, now it's working again. And then along comes the cloud, these pesky clouds, and it blocks out the sun. So then it stops working again. So what these guys do, they take out their flashlights, and then they actually now start walking, shining their flashlight onto the solar panel next to the thing. So that defeats the whole purpose of automation, because sometimes you automate something and it becomes so complex, you're doing more work than you did before. So now they're doing more work than they did before. So then what these guys do, they have another great idea. So they get this IKEA lamp and they get a big car battery and they basically strap it to the lawnmower. But now it has a different effect because the lawnmower is so heavy and it actually starts plowing the ground. It doesn't actually cut the grass anymore. So eventually what they do, they take this stuff off, they go and find every extension cord, every light that they can find, and they light this house up to the extent that you can even see it from space. Great, now it's all working. But did that really need to happen, right? Because if you think about it, solve for what you're solving. What was their problem in this case? Well, we cut the electrical cord. So join the wires back together and a bit of insulation tape, and the problem is fixed. Now, taking that into the cloud environment, if you were trying to control access from one machine to another machine, the simple access control list is really good enough. And especially if you take it a step further and you do it from an identity perspective, so you take the service account doing that role, you're shifting it from that. That's a very simple control, but it's effective. You don't need to do more than that. You don't need to create this really convoluted hub spoke model with all the traffic going through all these things and you're sniffing every packet and all those things, because it's a closed environment. You should be knowing that these two machines need to talk to each other. Here's what they need to talk to each other on. Fairly simple way. So keep that in mind. Number 4 is low barrier to entry, mind the step. So you can do a lot of cool things and a lot of easy things as well, but don't go and over-engineer things when you don't need to over-engineer things. So wrapping this up, if this was too long and you didn't listen, just remember these key takeaways, right? Make security usable to users. Because as we mentioned, if you don't, people will defeat your security. Assume services will be exposed to the internet and secure like they are. That's that mind shift that needs to happen. Then, this is a bit of a cliched one, but still an important one. Make sure that security is in everything and that it adapts over time. Because if you take that example of the time travel and the fence, you need to consider those different things. So maybe in 10 years' time, there's a new thing that replaces cloud, and we're trying to retrofit cloud principles onto the new thing. So make sure it adapts over time. Don't just set and forget. So security is also that business enabler. Going back to the brakes and the bow ties, security is the one, if you do it right, is actually going to make things successful. Next one obviously speaks for itself. Don't over-engineer. And then the last one, also a bit related to the time travel. They say that the definition of insanity is not hitting your head against the wall 100 times, but expecting a different result every time. So don't do the same as you've always done and expect a different result. Take that risk-based approach. Think about what are the threats to that. So if you're moving something into a cloud environment, think about what are the ways that things can go wrong. What are the risks for these things? And then make sure that you're actually doing the things that help mitigate those threats and those risks from that perspective. So with that, I'm going to stop sharing and I'm going to see if there's any questions in the chat or not. Great. So doesn't seem to be any questions at this point. German, I'm not sure if you're still there.
I am here, John.
Great.
Yes, you're right. There are no questions at this point. So from the Hackon team, I just have to say thank you very much for this presentation, John.
Great. Thank you guys for having me, and I hope you guys have an awesome rest of HackOn. There's some pretty cool talks that I've seen, so I'm going to be checking some of those. So yeah, go have fun, man.
Excellent. Thank you.
Thanks, folks.